If the positive integer n is a multiple of 24, 45, and 700, which of the following must be true? Well, here you need to work with the least common multiple of these three values, okay? Even though n can have infinite values, as the multiples of these three numbers are infinite, you can try the minimum value to validate the statements because it says it must be true. So if the minimum is true, then it follows that it will always be true for greater values of n. So now let's find the LCM of 24, 45, 700. Let's do this by factorization. 24 is 2 cubed times 3. 45 is 3 squared times 5. And 700 is 7 times 2 squared times 5 squared. Then the minimum value of n would be the LCM of these three numbers, 2 cubed, great exponents, 3 squared times 5 squared times 7. Let's validate statement 1. Since 27 is 3 cubed, can the minimum value of n be divisible by 27? No, right? This is not an integer because 3 cubed is not contained here. We only have 3 squared. So since the minimum value of n is not divisible, then it's not always true. What about statement 2? N is a multiple of 72. Let's try the division. 72 is 3 squared times 2 cubed. This number here, you can see is contained here. So when you try this division, the result is an integer. That means this will always be true. For greater values of n, this minimum value multiplied by some other integer, you will always have divisibility by 72. The third, you need to check whether n is greater than 12,000. Let's validate this with the minimum value. Is the minimum value greater than 12,000? Well, for that, you need to calculate this. Let's do it conveniently grouping the factors for faster calculation. This is 9 times 7, 63, times 2 is 126, but this represents 100. So times 100 equals 12,600. So the answer is yes. That means always true. And the answer is 2 and 3 are always true.